Okay, looking at some 6.2 homework problems here. The first one should be pretty easy if you were in class or watch the video of our class time together. They're going to give you the t-distribution. I actually had your table loaded up in here from your textbook, but they're going to give us the t-distribution just to go ahead and click on. It'll be right here for us. So we want 95% confidence, so we're going to live in this column right here. The sample size is 6, so that means we have 5 degrees of freedom. It's always n minus 1 degrees of freedom. So if our sample size is 6, we have 5 degrees of freedom. So for 95% confidence, real simple, we just go over to that row and column intersection, 2.571. And nearest thousandth would be 3 decimal places, I think. Okay. All right, let me jump to number 4. Those should be pretty straightforward. Go through. Find the margin of error for the given values of C, S, and N. So if you remember even from our first section, the margin of error is going to be, previously it was Z star, but now we're using the t-distribution, and we have sample standard deviation over square root of n. So that's the value of your margin of error. So the first thing we have to do here is figure out what that critical value is for 90% and 28 degrees of freedom. So I need that T star. So I go down to 28 degrees freedom, and we need to find 90%, I believe, for this, right? Let me see the picture again. Yeah, 90%, 28 degrees of freedom. So I can see 90% right here, 28 degrees freedom, so it's 1.701. So I'm going to have 1.701, and then we're going to multiply that by sample standard deviation, which they ought to give me, 3.3, divided by the square root of 29. Okay, that's our margin of error. It's still the same margin of error we had in the last chapter, except in the second section here we use T star instead of Z star. So it's really the same concept. So I'll just lean on my calculator for this one. So I have 1.701 times 3.3, and we want to divide by the square root of 29. Okay, and I get 1.042. So to 1 decimal place, it will be 1.0. Okay. All right, so we'll look at number 5. Here we're getting a confidence interval, start to finish. So the difference here from last section is that we're using the t-distribution now, but it's still a confidence interval for means. So when we come to our stat and test, just like we did in the last section, we want a t interval. Okay, it's number 8. 6.1 z interval, 6.2 t interval. Easy to remember and find. We do indeed have the stats here. They give us x bar. It's 14.8. They give us sample standard deviation, which is 4. Sample size is 8. It's a pretty small sample. And then we just tell them what our confidence level is. .95. Okay, so the calculator does all the heavy lifting for us. I get 11.456. So to 1 decimal place, that would be 11.5, right? and up to 18.1 to 1 decimal place. Okay, and we're good to go on that one. Okay, so let me jump. 6 is pretty similar to 5. 7, same deal. We're just going to do 90%, but this one says what's the margin of error, so we'll dive into this one. So the first thing we're going to do is get the confidence interval. So it's going to be very similar to the last one. We want to go to stat, test, and this is our t-interval again. So they give us the stats that we need. Our sample size is 21. The mean is 30.9. The standard deviation is 7.3. So those are the first two things I'll need to start. And let me just double check our confidence level here. 90%. Okay, so to start, we get the confidence interval 28.153. Up to 33.6. Okay, we're good on that. And then this takes it a step further. What's the margin of error? So we did this in the last chapter as well. So I have 28.2, 33.6. So if you remember, when I wanted margin of error, I subtracted those two. Oops. That's not going to work. We've got to subtract them in the other order, right? 33.6 minus 28.2 divide by 2. Otherwise, we get a negative margin of error. That won't make a whole lot of sense. So I'm going to do 33.6 minus 28.2 and divide by 2. And we divide by 2. So that'll be my margin of error, 2.7. Okay, and the rest of this just asks you for interpretation of confidence interval, which again is something that we've looked at in the last section, so I won't spend a whole lot of time looking at that tonight. We'll move on. Okay. Okay, so in number 11, they've already done a t-interval. They already did it for you, but now what they would like you to do is go ahead and do the z-interval like we did in the last section. But the first thing they ask you for is the margin of error. So in my opinion, the easiest way to do this is to just do the interval first. We could calculate the margin of error by hand by finding z star for 98% confidence. I think it's going to be easier just to take the data that they give us, the statistics that they give us, 33.5 and 7.4, and we'll just do the interval just like we did in the last chapter. So it's stat test, number 7 for z interval, and we do have the statistics. They're telling us that they know that the population standard deviation is actually 8.7 minutes. Okay. And then I go to X bar. Which was 33.5. That's not going to change. And then our sample size is 8 people. Pretty small sample. All right, and we know the confidence interval level is 0.98. Okay, so I'm going to go ahead and calculate that. And I get this interval here, 26.344. And all the way over to 40.656. And they want margin of error, so if you remember, oops, I always do that. We're going to subtract and divide those by 2. Just wrote them down in the wrong order, because I don't have everything on my screen at the same time. So 40.656. So I want to subtract those first, and then I'm going to divide that by 2. So that's my margin of error, 7.156. It's going to be smaller than what it was for the t-distribution. So at the 2 decimal places, that's 7.16. Okay. And then what's the confidence interval? Well, we have it right on our screen here. We just did it. 26.344. So to 1 decimal place, 344 would be just 3. And then it goes up to 40.7 if we round to 1 decimal place. Okay. So what do we notice about that? We notice the z-distribution interval is more narrow, right? Because we don't need, if we know the population standard deviation and it happens to be larger, we don't need as much degrees freedom or extension of our confidence as we would with a t-distribution. Okay, so let's peek ahead to, if I'm going to find to leave that question, number 13. So I'm not 100% sure if I was recording there, so let me just double check. We got a t-statistic here, 548.4. We take the statistic we got minus the actual mean that they're peeking behind the curtain and telling us, and then we divide by that standard error. This is coming from 6.2, right? This is the sample mean we got, sample standard deviation. Then they peek behind the curtain and tell us the actual mean. Okay, so we're going to place our t value here. That I calculated over here on the calculator, 1.71, so we'll follow our rounding rule for that. So we're trying to figure out if this is an unusual t-statistic. So if they give us our t-distribution table, which they don't give us here in this problem, but if you have it handy in your textbook or in the formula card, you could look up the t critical value for 95%. Or we can use the inverse t feature on our calculator, like 95% in the interval plus a 2.5% in the tail. 7 degrees of freedom. The sample size was 8. So I get 2.36 is what would be eyebrow raising to us. So 1.71 does fall in there because t critical for 95% for that many degrees freedom is 2.36. Okay, a little bit of a difference with number 15 in that you have the actual data. So what I'm going to recommend anytime we have the actual data here is that we use StatCrunch. Okay, so I'm going to open this up in StatCrunch. All right, I think it's going to make things a little bit easier. So I just think it's going to make things a little bit easier rather than putting all these numbers, and you'll see some of the data sets as we move on are many more numbers, more decimal places. It's just going to take a long time to put them on the calculator, and StatCrunch will do everything for us, and I can kind of quickly show you how each thing works that we're going to need to take advantage of. So we open up in StatCrunch and it already has our lists in there for us. So if I go to Stat, all right, remember what we're trying to find here. we're dealing with a t-statistic, right? Because we're trying to find a confidence interval, and it's a one sample deal. Okay, so what we have here is we have the data. We don't have the summary statistics. Summary statistics would mean if we have the mean and the standard deviation. We actually have the actual data. So when we click on that, we have the list. We're going to click on variable 1. We'll do hypothesis tests next week. Okay. Right now, what we're dealing with is the economy of confidence intervals, right? So if I can click over here for 1 second, it's not asking me what level of confidence I want, so I'm going to have to guess for a second here. I'm going to go ahead and go with a 95% confidence level. We have to change that later. That we can change that pretty easily, but I want to show you what happens with StatCrunch when we use it. So I hit compute. It gives me the sample mean. So that's the first thing this asks me for is the sample mean. It's 2.29, right? Round to 2 decimal places. So it gave that to me, 2.29. Okay, StatCrunch does the heavy lifting for me. Okay, then it says find the sample standard deviation. So let's go back into StatCrunch to see. Does it give me the sample standard deviation? Shoot, it doesn't. I thought it would give that to me. Okay, so not a problem. We're going to go to data. Sorry, we can go. What we can do is go to stat and summary statistics. That'll be a quick way to get it, and we have a column. Okay, so our column is variable 1, and summary statistics will get us our standard deviation really pretty quickly if I compute that. So my standard deviation is 1.12. Check answer. Okay. 95% confidence. Luckily, we already did that. Let's see if it's still in my StatCrunch. Close that. Yeah, it's right here. Here's my lower limit, 1.579, which would be 1.58. And then my upper limit, still here in StatCrunch, 3.00 to 2 decimal places. Okay, so StatCrunch does all the heavy lifting for you in that case. And again, I would recommend using StatCrunch in any of the problems where they give you lists of numbers. Right, same thing here, big list of numbers. Use StatCrunch for that. Sample mean, just follow the template that I gave you previously. Okay, so that's the 6.2 homework tutorial. I'll move on to 6.3 next.